All right, so what we're going to do today is we're going to use the product rule, but we're also going to use just regular old power rule. Now, if you try to use power rule right here, you have to do something first. You have to turn it into a polynomial. Right now, it still says that two things are multiplied, right? Okay, so we're going to do this two separate ways. First way over here is power rule. And this is what you're going to be asked to do today on this little worksheet I got for you. So power rule. In order to do that, we need to distribute some stuff, right? So let's do that. Let's work this out. Let's distribute here. So we'll have x to the fifth and then plus x squared, right? That comes from these two. And then minus 2x to the third minus 2. Now, if you rewrite it like the power rule like that, the derivative is really easy from there, right? Okay, so let's do that. Let's go. What's the derivative? Yeah, each one. Yeah, let's, well, I guess we'll leave it like that. And then nothing, right? It's gone, 0. So if we rewrite it in whatever form, whatever, there's our answer, all right?
Do you have to put it in like the order of the exponents?
It bothers me, but no.
Okay, because I think for one assignment you had to.
Oh, really? Did it say standard form?
Well, I think it was like a while ago in one of our classes.
There's one like that in Algebra 2, yeah.
Are you enjoying feeling like you're seniors? Yeah,
Hang on. All right, so if you do it the other way, we're going to do product rule. Now, we can use product rule because what's in the middle of these two things right here? They're multiplying, right? We just never write it. So if we're using product rule, so this side right here, product, writing with a mouse. Anyway, we have two parts we need to do, right? U is the first one, remember from yesterday, right? V is the second one. And then we need to find the derivatives of each of these. All right, so when we write our answer, it's derivative of the first times the second, right? U prime times V. So that'd be 2x. Make sure you use parentheses. You're going to see why in a sec. So that's those two. Whenever you draw it out like this with U, V, U prime, V prime, and then you do this, it kind of makes the little x like times. I don't know. I like that. What do you put in between the two, though? Plus, yeah. So now we're going to say x squared minus 2 times 3x squared. You can see in this case already the product rule is a lot longer, right? Yeah. There are times when it's not going to be like this when we get into the chain rule, which is next or after the quotient rule. Anyway, so here's what I want you to do. This is an acceptable answer on con, but today what I'm going to ask you to do is show that these two things are the same. Show it. Like work it out, one side, the other, prove that they're the same answer. All right, so I mean, technically at this point, you could work either way. You could try to factor something out of this, or you can just expand this. So let's just expand. That's a little easier. All right, so here's what I'm saying. This is 2x to the fourth plus 2x. Over here, we have to distribute. Yep. And then minus 6x squared. Now, when we go back and forth between product rule and power rule, some people want to get to here and then like do some weird power rule at the same time. You don't have to, right? You don't have to multiply by the power and subtract 1 from the power. That is the derivative right there. We are simply rewriting everything, Okay. So if we combine like terms, the last little thing, we can combine this with that. And then when I say show that they're the same, that's what I mean. The right side is the same as the left. We use two different rules though. There are times when this side's better. There are times when this side's better. Okay. That's the whole thing if you're still writing down. Any questions on that one? Okay. Here's the next one. A little different. It's got a square root with it. We're going to do two different ways as well. Same thing. This side will be power rule. So power, and then product rule on this side. If you want to use the power rule, the first step is going to have to be distributing, just like on the last one, right? We just had two binomials, but now we have to distribute. Keep in mind, this is the same thing as t to what power? 1/2. Yeah, it's a square root, right? So when we distribute, we should really think of it like t to the 1/2 that we're distributing. So here we go. If I take this times t to the third, I have to add the exponents. So the question is, what is 3 plus 1/2? Right. Yep. 7/2. Right. 3 is 6/2 plus 1/2, 7/2. So keep going. Right. Now, this is just a rewrite. That's all we've done. So now let's differentiate. Let's diff. Using the power rule. We can use the power rule because we have two things that are being added together, right? They're no longer being multiplied. So let's go. Let's do this. Multiply by the power. Subtract 1 from the power. Same thing over here. Multiply by the power. So 1/2 times 2 is 1. Don't have to write anything. Yep. Now let's just kind of leave it like that for a second, and then let's see what we get on the other side, okay? I don't need any particular form, but we're just going to prove that they're both the same. All right, now, product rule. We have two different things. This is our U, right? This over here is V. So what's the derivative square root? Well, it's 1/2 because that's the exponent. T to the negative 1/2. I'm going to leave it like this because that's the kind of form over here. We're trying to prove that they're the same, right? Okay, over here, V prime. So now we can combine. Let's multiply. Let's use our product rule, right? Derivative of the first times the second. Very messy. Plus the other combination. Well, I don't like how I have two different forms there, but that's what I wrote up there, right? All right. All right. If you wanted to do this instead, if you wanted to write t to the 1/2, that's fine. It's the same idea. We still have to show that they're both the same. Okay. Whew. Now what? Yeah, let's multiply here and let's distribute over here. So we got to distribute some stuff right there. 1/2 t to the negative 1/2 times t to the 3rd, right? So that means when we do this, we're adding the exponents right there. 5/2, yep. And it's 1/2 t to the 5/2. And then the second part of that is here. So that's 1. That's 2 times 1/2, so that's 1. Then the other side, we're multiplying, right? I crossed off the square root to rewrite it like an exponent. So I've got to add the exponents. Add those two exponents. What's 2 plus 1/2 as a fraction? As one fraction. What's that? Yeah, 5/2. That 3 is still there. We're about there, right? All we need to do now is show that they're the same. So the only thing left to do is combine any like terms. So right here, these two things, that and that, they have the same variable and they have the same exponent, right? Those are like terms. So I can combine them. So I'm adding 3 plus 1/2. Same thing we did earlier. That's 7/2. And now it matches the left side. Just like so. Okay. So one part of what I'm going to give you today is like this. And then there's another one with some trig derivatives. I want to show one of those, but you won't have to do it two different ways. You just have to do it one way. Product rule. So it's going to look funky because product rule means two things are multiplied, right? But what's this say? Divide. Now, what we could do is rewrite this. How can I rewrite it? Kinda. It's kind of that idea. How can I rewrite dividing by t squared as multiplication? So it's -2. Don't confuse it with radicals. It happens all the times, right? Yeah, right. If you are dividing by something like this, then that's the same thing as multiplying by the negative exponent of that. Negative exponents mean divide and vice versa, right? So you can rewrite your situation like this. And then you could say that's u, that's v, and then go from there, right? I won't continue on this one. I think we can handle it from there. Just a couple things. Don't forget, what's the derivative of sine? Cosine. And what's the derivative of cosine? Yeah, opposite sign, negative sign, whatever you want to say. Okay, so I've got this paper up here. Could you pass those out for me?